Alright, so this is going to be the weather observation, how to take it here in Tempe. So I'm going to do this little video to kind of help teach, not necessarily teach, but to do this. So I just need to put my name and stuff. Maybe if the pen actually worked. I got a fucking pen in my. So this is what the sheet looks like. I'm gonna take all these calculations in just a second. Today is the 26th of April, 2016. Current local time is 17:53. Local Arizona time. Alright. We're gonna take this little rain meter. We'll go out here to this. This is an entire weather facility we have here at ASU. So this is our rain collector. How you do this is you're going to slowly put the stick in. It's Arizona, so there's not much rain. And you're going to let it sit there for just a second. Slowly raise it back out. You're going to look for any type of wet mark on it, and because it is Arizona, there is no water, so that means no rain fell. So, right here where it says precipitation in inches, I'm just going to write 0. And then right down here in the evaporation thing, I'm just going to put another 0. So then we're going to come out here, we're going to look at the thermometers. And don't worry, I'm still here. Just have to get the key out. Oh man, what did I do with the key? Oh, it's in my pocket. Good thing. I was about to freak out there for a second. I'm going to go over here. This is where our thermometers are housed. I'm just going to lift this little panel up and then lower it. So we have 2 types of thermometers out here. Alright, we're going to have our maximum thermometer on the bottom and then our minimum thermometer at the top. So, in this thermometer, the maximum, you're going to see, so it's really hard to see. There's a little silver line, and you can see it kind of ends right there. That little line right there. So that's going to be our daytime high. So it looks like today, our daytime high was not very high. Roughly 77 degrees. So down here for the maximum, I would put 77 degrees Fahrenheit. You always want to put the degrees, the unit on there. So then how you're going to do this is there's a little clip on the back here. You're going to move that. And then what you're going to do to reset it is you're going to just spin it once. And then spin it again. That was a really bad spin. That's a much better spin. That to stop for a second. And then you're just gonna lock it back into place. So now it should be. So now it says it's 86 degrees. So it went down a little bit. What it'll do is it'll reset itself to the current temperature. So it'll reset itself. So right now it's 86 degrees. So I'm gonna write 86 degrees Fahrenheit. Ooh, my bad. It should be 76. 76 degrees Fahrenheit. I always want to make sure you keep that track. So for the minimum, this is the minimum scale up here. What you're going to do is you're going to look at the line, and it's going to be this side of the line. This side of the line will tell you that it's the this side of the line will tell you what the minimum temperature was. So it looks like today the minimum temperature was only 53 degrees. So right down here you're gonna write 53 degrees Fahrenheit. And then how to reset this is you're just gonna lift it all the way up there, let it go down, and then as it gets cooler, this black line up here is gonna just start to slowly sink until it got as cold as it did, and then it's just gonna stop there. Whereas this line will actually just continue to drop. It'll just continue to just move wherever it is. So tomorrow, if it's not as cold or if it's not as warm, then it's gonna be a little off. But if it's gonna be warmer than it is today, then this silver line will just continue to go ahead. That's how you do the temperature. I'm gonna close it back up so that way we have that. That's another cool part. So in here, what we're gonna do, let's see, for the anemometer reading is we're just gonna read this number here. It's 4869. 4869. That does not tell you the wind speed, because 4,869 miles per hour wind speeds, that would set a record, and I would not be standing here currently. That's just how many. That's just how fast the wind has gone in a while. So now we're going to do the precipitation. But first, we're going to look up at the sky. We're going to look at all the clouds in the sky. So we got some clouds up there, some over there. It's going into the sun a little bit there, some up there. So what we're going to do is we're going to look up at the sky and determine the cloud types. So low, medium, high. I'm going to pretty much say that they're going to be, they look like high clouds. So we're going to put high. And then we're going to put the sky cover. What percentage of the sky is covered? I would say roughly, say about 20%. It's really just a guesstimate on that one. So, you see here we have our current observations. Okay. So now we're going to come over here and pick up this fun cylinder of water. What we're going to do is now we're going to check the evaporation rate. So we're going to lift this thing up. Slowly bring it over here. So what we're trying to do is, this is our evaporation pool. There's a little thing right there in there. What we want is we want the water just to touch the very top of it. If we come out here and the water is already over the top, that means that we had a huge amount of rain. And then what we do is we would take out water until it was at the top, and then measure how much water fell into the evaporation pool. If it's lower, like it is today, we're going to add water from this cylinder. We're going to keep track of it. There are numbers on the sides of it. That stands for each 1/100th of a inch that evaporated. So we're going to slowly pour in some. So we right now put in 800ths of an inch roughly. So we're gonna let it just kind of sit there for a few minutes, kind of let it soak in. It's pretty amazing thing we have here. So what we're gonna do after we take all the observations, first we're gonna call the state climatologist, whose name is Nancy Slover, and we're gonna tell her pretty much all the observations we have besides the sky condition. Usually, what we would do is we would call SRP and tell them how much evaporation there was, but I was told that we do not have to do that currently. Because they're still kind of filling up Tempe Town Lake, and that's why they need the evaporation, so that way they know how much evaporation was it came out of Tempe Town Lake. But since it's not even full yet, I don't think they're actually doing much with that. So still low. I'll still give it a couple more minutes. Let's go see how much the last couple days have recorded in evaporation. It's been kind of warmer the last couple days, so I would assume that the evaporation level will be a little higher the last couple days. Yesterday, they had 0.49 inches of evaporation. The previous day, they had 0.34 inches in evaporation, and then the day before that 0.23, and then the day before that 0.26. So the other day they had a pretty good size evaporation level of 0.46, I believe. That's a pretty impressive number right there. So we're gonna fill this all the way up. So what we're gonna do is we're gonna come over here. We're gonna just put more water in. And what we're gonna do is we're gonna keep putting water in until until it gets full. So I'm gonna set the phone down just right here. So we're gonna put some more water in here. So we've already gone through we're almost getting to about 0.2 of an inch right now in evaporation. So I'm gonna go ahead and top it off at 0.2. A little more than 0.2, but that's all right. So you see, it's getting closer to getting full. Still got some more time. It's an amazing feature. Hopefully, I can do this one day after I get my PhD in meteorology. So we will. Just kind of wait here for just a couple more minutes until we get this water level up. right there just for now. This part's like the worst part of it, the slowest part. Got a bunch of this stuff here so that way birds aren't drinking out of the water and affecting this. So what all this data is used for is it goes to the state climatologist, who then puts it in the system for the National Weather Service, and so that way it gives the National Weather Service data for today. But not only that, it also gives like in 10, 20, 30 years, they can go look back at data, whether it's today or this month or just this week, and look back and see how the climate is changing, just based on the weather observations from today, and then today a year ago, and then today from 3 years ago, today from 5 years ago, and so on, for as long as they've had data for this weather station for. I don't know how long exactly this weather station's been around, but this is one of the main weather stations here in the Tempe area. I'll put in just a little bit more. We're almost getting to the top there. So right now we've put in roughly 0.26 inches of water. So that's about a quarter of an inch of water. Quarter of an inch of water. So that's pretty impressive. And I know it doesn't seem like a lot, but when you look at the how much volume is in that water pool, it is only about an inch. It's really a nice day outside. When I did my mandatory observations earlier in the semester, it was hot. Let me tell you that right now. It was hot, hot, hot. I'd say just put just so. Okay, so we're at about 0.28 inches of water. And I'm gonna say it's pretty good right there. It is near the top of that spindle there. So I'm gonna call it at 0.28 inches of water added into it, into the evaporation pool. So that means that today there was 0.28 inches of water that was evaporated. So for this, as you see here, if water was added, put a plus. So we're gonna put plus 0.23. Sorry, 0.28. I keep messing up on that stuff. So the evaporation then will be plus 0.28. So what we would do here, okay, is the change in the water level. We would determine it by precipitation, and then evaporation, and then it would give us our total change in water level. So if we had to remove water, it'd be minus, and then however much we had to remove. So that's pretty much all that there is left to go in the weather observations here. I'm gonna go ahead and take one more quick look at it to see how it looks. I'd say that's pretty good right there. It doesn't have to be like exactly at the top, but it's got to be somewhere close to it. So pretty much all that's left is we're gonna fill up this graduated cylinder right here, and then we're gonna fill up this water bucket here, so that way the person who does the weather observation tomorrow has enough water to put into that evaporation pool. So that's gonna be the anemometer right there. You got the rain gauge right there. The
thermometers are both there. Okay. You're gonna have another anemometer up there. Looks like also a barometer. You got a lightning rod up there, so that way if there's lightning, it'll hit that long rod right there. And then over here looks like another barometer and an anemometer, so it's pretty nice. That's all we have here. Of course, if you go to an official National Weather Service weather site, you're going to usually have more weather instruments there, but we're just university, so we don't have too much. So I hope y'all learned something new today, and I hope y'all find weather just as interesting as I do. I'm signing off now.